Hey guys, welcome to Ultimate 3D Prints. Today we're going to learn about support materials and what is a support material. Alright, first we're going to open this test right here. So this is a file I got off Thingiverse. It's basically something your 3D printer can print out, and you can just test out stringing, supports, and I'll go over what everything is in a few seconds. Alright, so basically supports is where anything hanging in the air, like this red part on top, nothing's supporting this. So if this starts printing it out in the air, what it's gonna do is that gravity's gonna pull it down, and it's gonna turn into like a fuzzball right here in the air because it can't print directly in the air. So that's basically what support material is, and I'll put some pictures of real life support material for a few seconds here. Alright, so that's what support material is. So basically the 3D printer is pretty impressive. Like the one I have, the Ender 5 Plus, it can actually print up to 60 degrees right here in the air, which is pretty cool because all of this doesn't need any support material. After 60 degrees though, I've noticed that it does start to fail and warp and disfigurations, and basically it's printing in the air. So it's not getting attached to anything. Here it's getting attached to the last layer, but in the air it can't really do that. So basically you need support material anytime you're printing something that has nothing under it. So basically on a helmet that would be the ears. There's nothing on the side of the ears, so it's going to need support material. On a hand, let's say it's facing fingers up and then just bending them slightly. That'll be the support material I show in the picture. For each of the fingertips, they're going to be in the air. Then that's what support material is used for. Where else would you need support material? Basically, a lot of the prints have support material. But basically what support material is just supporting the layers that have nothing nothing directly below them, so it can print nicely. So we're going to go ahead and show you exactly what they look like once this is set up. Preview. So this is Cura showing you all the layers it will print in fine detail. So each one of these yellow lines, ignoring the shadows, is each layer. So right here you can see that they've nicely put the angles at which this is in the air, compared to straight would be 0 degrees would be this straight up, and then off to a little bit it's 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, and then 60 degrees. So basically these are the angles away from this 90-degree line, invisible line that goes straight up and down. So anything after 50 to 60 degrees, you're going to want support material. And let's take a look inside the support material so you can better understand how it's helping the 3D model. So right here you can see the support material is really just a hollow shell with some lines on the inside to give it some rigidity, so the layers on top can actually print on something solid. So basically what happens is your model gets printed at the same time as the supports, and what the supports do is they support, like they're called, they support the model on any parts that has nothing directly under it. So basically right here, if I deleted supports, imagine this was gone. Each one of these layers would be connected to nothing. And what I mean by that is that the layer I'm pointing at right here, this one would start printing in the air because there's just nothing directly under it. So basically gravity would win here because the material is so thin, and basically it's going to start printing in the air because the last part that had some good adhesion was at this 50 degree, almost 60 degree angle from this line. So basically support material lets your printer print things in the air. Pretty impressive. What I've noticed is we're going to go over some settings because the support material is also something that you guys will probably hate when you first start out. So sometimes, well, most of the time when you get started, the support material gets so stuck to your print that it basically becomes unusable. The print becomes unusable because you try to rip the support off, and the whole print that you actually wanted to display or use gets ripped off as well. So we're going to go over some few settings that can probably help you out with that. Alright, so right here you notice there's a little gap. This gap is 0.2 millimeters thick, and I know it doesn't look like that here, but I'm really zoomed in. This is actually a really tiny print. But yeah, let's go back to before the preview. So right here you can see this is the top of the supports. What you don't want is your supports to weld themselves onto your model. So here we're going to go over the settings. So here in the Cura settings, I'll make another video going over all of them. They're pretty self-explanatory, but there are some special ones I want to talk about in the support section. My next video will probably go over all the settings, but this is something most people don't take into account when they're printing their first prints. Okay. The first line on the supports, I have some extra lines just from the additional settings right here. Because I like to be in control of a lot of the stuff in Cura. Because once you fine-tune things, you can make profiles, and each of these profiles can go for small models, large models, so you don't have to really mess with them more than once. So, support. Generate support. On some models, you'll notice, and I'll display one in a few seconds over Cura right now. Some models, you don't really need support material because the whole model has angles that are in the air of less than 60 degrees. So basically how you find that out if your model has can be printed without supports is you go to support and you just change the angle, or is it overhang angle, to 60. Once you do that, you'll notice if your print needs support material or it doesn't need support material. For example, let's say if I lowered this to 40. Slice it one more time. Remember, our supports were here at the 60 mark, 60 degree angle mark. Now you notice that there's more supports. Why is there more supports? Well, you just change the angle to start supporting material to 40 degrees. Now here, you don't really need support material, and you can print this test without support material just so you can see what your printer is capable of, but most printers, I think it's about 50 and 60 degrees that you need support material after that, but they do pretty fine in 40, 50, and maybe 55 degrees. So basically, yeah, that's what your support angle does. It tells Cura where to put support material. So let's go back to 60. Alright, so we're back at the 60 degree mark. Let's go over all the rest of the settings. The support pattern doesn't really matter. This is the pattern that goes inside your supports. So basically, if I cut it again down the middle, see these lines? It's just the shape of what these lines look like. It's not really important. Zigzag just means it's going up, down, up, down. I noticed that's the fastest because the motors are easier to move in one direction than creating like a spiral. But you can choose your own, you can experiment with your own, but I've always used zigzag, the one that's default with the support material. The next one is support density. See, if you want your supports to come off really easily, I would keep this number low. There's no reason the piece that you're going to pop off the model should be as thick as the model. So I usually keep my support density between 10 and 15. I've noticed if you lower it less than that, this is what happens. It gets so thin that on tall pieces like this, like it's going to print out pretty tall, it is so thin that it starts to not really be straight up here. It starts to really the heat of the bed start warping it, and basically as it cools, this is warmer than up here. So if anything shrinks down here, this top part is actually going to be over here slightly, over here slightly. You'll notice that it won't print directly above it if your support density is too small, because literally each one of these lines are 0.2 millimeters thick. So don't go too low with that. Let's go back to, what was it, 12? Alrighty, we're back at 12. See, this is a lot better. If I had a measuring tool in Cura, you could see that this is actually like a centimeter, and before it was actually like an inch apart. So it keeps its shape better with the higher support density. But there's no reason this should be ever over 15 unless you have some really, really big supports that you need. Support Z distance. So like it says right here, this is the distance from the top or bottom of the support structure to the print. So this gap, like it says, provides clearance to remove supports after the model is printed. These supports aren't going to stay there, and you'll notice that the first thing you do when you take your models off is to remove the supports. So what you want is a distance between the support and the model. And you might be asking, wait, then what's the point of the supports if they're not really touching the model? The thing is, gravity is actually pulling them down ever so slightly. So every few lines will make just enough contact with the support so it won't really droop, like go into the air. It actually weld, think of it as a spot weld. Gravity will make these little spot welds between your model and this line that will basically keep your model's shape. So that's what the support material does. At least that's how I use it. So when you go to take it off, there won't really be a gap here. Gravity will cause these parts to actually join ever so slightly, and when you pull the support material off, that gap that is in the rest of the non-spot welded spots will be enough for it to pop off, theoretically. It doesn't always work out like that, but that's how it works. Support top distance. This is basically this support Z distance, but this just is a little bit more specific. This is the top, so this right here. Support XY distance. I keep this higher because you don't ever need supports for X and Y. You want to know why? This should be self-explanatory, but I'll explain it either way. That would be like having support material on this vertical column. This has enough adhesion to the bed that, of course, you don't need anything next to it. So your X and Y distance, I would keep pretty high. I have mine at 0.8. You could probably go higher, but that's how I have it. Support infill thickness. This infill is the thickness per layer of support of infill material. So this is basically the layer's thickness. I would probably keep it the same thickness as their model, because or else your bed's going to have to keep moving up and down to compensate for this layer thickness and your model layer thickness, because it prints one line at a time. So that's what that is. I wouldn't change that. I haven't really messed with gradual support. Let's go over a more important part. Enable support interface. So basically what this does, it makes a little bit thicker of a material right here, closer to the model, than the rest of the supports. For you to see this a little bit more, we'll take a look inside here. This is the inside of the infill for the support. You'll notice that there's big gaps between. That's because it can actually print bridges, which is basically a line over nothing between these support lines, a lot easier than printing in the air. So basically this prints in the air maybe a centimeter and then attaches itself to this point. So that's enough support line. That gives it enough adhesion to not fall down and quickly connect to the next support. So basically think of it as the liquid plastic solidifying really quickly because of the 3D printer's fans. Basically like a 3D pen, I don't know if you've seen them, they actually print in the air with something under them, not too far, but basically this prints in the air, dries, and it does it at the right moment where it doesn't it doesn't let gravity affect it. So basically that's what that is. This interface though, the top of it, the part that touches the model, this part you want it a little thicker, because what will happen is if these spot welds turn into like full welds, like full lines connected to the model, what will happen is you'll have a really hard time peeling off the support off the model. So since the model is thick in infill, well, not too thick, but like thicker than the support, what will happen is sometimes that, let's say this is 12%, this is 15%, they'll be so close that maybe this part of the model will fall off or come off when you pull off the support. So what you want is this interface, which makes a little thick layer of the support right next to the model, so it can keep its shape better, and it actually won't warp like the rest of the support might, to give it that rigidity. So when you're holding the model and you're holding the support and you pull them apart, they actually have a breaking point. You want the breaking point to be right here between the two thick layers. So what will happen is this layer is thick, there's a tiny gap here, and this layer is thick. If this layer was thin, the support will probably come off in small pieces and it'll take forever. But if you make the interface thick enough, what's mine at? 0.8 millimeters. If you make it this thick, and this is thick, then the crack when you break the supports is going to happen at the area of least resistance, which will be these spot weld parts that I talked about earlier. So that's what the support interface is. It just gives it a little bit of thickness next to the model, so it'll have a breaking point. Interface density, it doesn't really matter. I have mine at 80 just so I have a quick snap off, because I like my support snapping off ever since that problem with a Gundam I had, and you've probably seen it in my other video. And support floor line distance, so this will keep a little some spot welds down here as well, so they won't stick to the bottom of the model. This isn't a really good picture. Let me see if I can find one. You can't really see it, but trust me, there's a little gap in between the model and the lines. It's really hard to see, but there is a gap, at least inside of the support. It's like it skips a layer. There we go. Skips, and then there. That's the gap it's talking about. So basically, it won't stick to the bottom of the model either. That's what this is. And one last thing, support interface pattern. I like concentric because I feel like when I'm pulling apart the model and the support, when I'm pulling off the support, this printing in a circular motion doesn't give it a starting point or ending point like a zigzag line does, because when you're extruding and you stop here and you move and you stop and you move and you stop, what will happen is that if that happens more often, then what happens is there's points that have a little bit more extrusion than others. And concentric, it doesn't ever stop. It just keeps moving and moving and moving and moving. And zigzag will go like this, stop, go like this, stop, go like this, stop like this. So concentric, I think it's a lot better for support interface. So that was my video on supports. I hope this really helps you. I wish I had this video available when I was learning about supports. I haven't 3D printing since 2009, but that's back in school. And oh, one more thing before I go. These bridges down here, I want to go over them. So see, this is a little test I got a Thingiverse, like I said, that whatever this comes out of your printer is where you can make some fine tuning. So basically, this is a stringing test. It'll print these little columns, and you notice any string, you can adjust your. I'll go over all the other settings in my next video. You're just gonna adjust your travel and your retraction. Basically, what this does is backs up the filament so it won't ooze out while the printer head's moving. So if the printer has to move here to here and it doesn't retract, what will happen is that there'll be a tiny little line here caused by gravity and the plastic melting that you can adjust in these settings. So one other thing I wanted to go over, these bridges, of course they're going to need supports, but what this is doing is it's showing you how well this prints without supports. So these will probably be fine because of that, because of the plastic solidifying in the air with the fans, but these might start to look like crap. The way you remove supports from a material, that's what I wanted to go over before we go, is you click the model, and down here, we'll go over all these settings in the next video. down here there's a support blocker. You basically just select that and select where you don't want to support. And let's say you don't want any supports down here. You select it, you go back to scale, do not uniform scale, move the size of the place you don't want supports, because we still want supports up there, but no supports for anything in here. And then you just press slice. And that's basically everything in supports. I hope this helped you guys a lot. I know it's going to help you a lot because I wish I had this video available when I was learning. And I made this a long video because I wanted to go over in depth what each one of these options do for support. And I'm pretty confident that I went over everything for supports. Yeah, I hope this helps you guys out. And thank you for watching.